Hello, everyone. I hope you're having a good GDC. Woo! Okay, this is Haptics and Interactions with the Presence Platform. My name is David Nelson, and I'm a software engineer at Meta working on Interaction SDK. So I spent nearly a decade working in the AR and VR space using Unity as a Unity generalist sort of from the early like DK1, DK2 days. And I'm currently specializing in interactions. So Interaction SDK. What is Interaction SDK? Quick show of hands. How many people here are familiar with it, have heard of it? Okay, that's pretty good. How many people have used it in a project or attempted to use it in a project? All right, that's pretty good. So Interaction SDK is a production library that makes it easy to add controller and hand interactions to your Unity MR experiences. Some of the interactions we provide are raycast interaction, poke interaction, which is like direct touch on surfaces, grab with hand posing, use, which is a layered interaction, and like squeezing the trigger of a spray bottle, locomotion, transformation, which is moving and scaling and placing objects in 3D space, and then pose and gesture recognition. Some of the inputs we support are hands tracking input, controller input, and controller-driven hands. And this is posing the hands using controller data. So how do you get Interaction SDK? Well, Interaction SDK is available on the Unity Asset Store from the Unity Package Manager in 3 packages. There's the XR Interaction SDK, which is our base package and kind of contains our core scripts and assets. You have the Interaction SDK OVR integration, which ties this base package in with OVR plugin and the OVR camera rig. And then you have the Interaction SDK OVR samples, which contain all the sample scenes and assets using the OVR camera rig. All right, so I want to talk about some new platform-level features that Interaction SDK supports. So in our latest releases, we've introduced this feature, multimodal input. Now, this is simultaneous hands and controllers. So this means hands and controllers together. So instead of saying either or, the user has to use 2 hands or 2 controllers, now you can use one of each. And some of the use cases for this, you can see the video here, where the user has a controller in their right hand, and they're using their left hand for hand tracking to load the balls into the slingshot or the ping pong paddle. You could use it if you want using hands experience and you want the user to grab a controller to use a tool or use the buttons or have sort of the fine control that a controller offers. It also gives seamless and instant transitions between hands and controllers. So no more waiting for the controllers to kind of go to sleep and your hands to sort of wake up before you can use hand tracking. You can just sort of put down a controller and then boom, you have your hand. And the other thing is improved social presence. So if you're using one controller previously, and you have your other hand with no controller, your hand would kind of hang down by your side because we don't know what to do with it. But now we know what to do with it because we're tracking it. So we get your hand and you get the controller at the same time. So another new platform-level feature that Interaction SDK supports is CapSense hands. So CapSense is a capacitive sense from the MetaQuest controllers. And what this does is, it's what I talked about earlier with controller-driven poses. This basically says, your proximity of your fingers to the buttons we use to pose your hands. And so you could do things like have your avatar use hands in an experience and not just have their hands kind of crushed into a controller pose. You can have your controllers, or your hands holding the controllers in the game and use your index finger to poke if you want, any kind of combination of that. But it gives you realistic poses while you're using controllers. And the third new feature is wide motion mode. Now what wide motion mode does is sort of fill in the gaps in hand tracking data with body tracking data. So in practice what this means is if my hands are outside the field of view of my headset, previously you'd end up losing, or without wide motion mode, you'd end up losing hand tracking because your headset can't see your hands and can't track it. But our body tracking engine can track your arms and your elbows and actually extrapolate your hand poses from this and fill in some of those gaps. So when you're moving your hands around, they're outside of the field of view of your headset or in the peripheries, you're not going to lose hand tracking nearly as often, and so that's what wide motion mode provides. Okay, so those are some of the new platform-level features that Interaction SDK can leverage, but these are some usability improvements that are new in Interaction SDK specifically. So why usability? So I saw a bunch of hands of people who have used Interaction SDK in the past. This might ring true for you that it can be a lot, right? If you start getting the package and you start saying, all right, I want to actually make things interactable, it could be a lot of components, a lot of assets, a lot of things to learn before you're able to just get something started. So with that in mind, and with that feedback in mind, we have introduced 2 new features in Interaction SDK in our latest releases, which is Quick Actions Wizards and the comprehensive rig prefabs. What Quick Actions is a right-click context menu that you can right-click on an object in your scene and add interactables to it. For those not familiar with Interaction SDK, the interactable is the component that lives on your scene objects and enables interaction with it. So for example, a canvas would have, if you wanted direct touch or poke, you'd have a poke interactable or a raycast interactable, you'd have a hand grab interactable, and so on. These live on your components in your scenes. Previously, you would have had to either tease apart sample scenes or prefabs and try to cobble things together into your own scenes, but now you can just right-click on the object and add the interactables and go. It doesn't quite stop there because Quick Actions also lets you add the interactors. Now, again, the interactors are sort of the other side of the interactor-interactable pairing that Interaction SDK has as its core. So interactors tie your input devices, meaning your hands or your controllers, with the interactables in the scene. So for every interactable type, you need an interactor type. You need a raycast interactor on your controller or on your hands. That lives in your camera rig or your player rig or OVR camera rig adjacent. And so this is something that Quick Actions also adds. So the interaction modes that Quick Actions currently supports are canvas poke, canvas raycast, hand grab using pinch or palm, or distance grab, the three types. So the three types we support are grab relative to hand, so I can grab something at a distance and kind of move it one-to-one. Pull interactable to hand, which like sucks the interactable into your hand, and manipulate in place, which actually sends your hand to the interactable so you can kind of tweak it where it is. So the second new feature in addition to Quick Actions is the comprehensive rig. So the comprehensive rig is a fully featured, pre-built rig that includes all these interaction components wrapped around OVR camera rig. So instead of having to import OVR camera rig and the interaction stuff, wire everything together, add hands to the scene, add controllers just to get something working, you can now start from an empty scene, drag in OVR camera rig interaction, and you're good to go. Along with the comprehensive rig, we have the comprehensive sample. Now, the comprehensive sample is more of a real-world showcase of what ISDK can do. So previously in ISDK or in previous versions, we've had something like the grab scene, which shows like, a bunch of different variations of grab interaction or raycast interaction, but sort of isolated from each other. But in a real experience, you're going to have a lot of these interactions working together, and they have to hand off and work together so you don't have, locomotion firing when you're trying to raycast, et cetera. So the comprehensive sample demonstrates all of these. And as you can see in the video, we have a tablet with poke interaction that's scalable and movable. We have a distance raycast canvas, and we have locomotion and grab, et cetera. Okay, so all of these sound really great, on paper, but I want to give a quick walkthrough of what this actually looks like to set up in Unity. So we're going to build a multi-interaction scene. Now this scene includes raycast on canvas, as you can see, poke on canvas, I'm poking the buttons and scrolling it. Includes distance grab. This is the pull interactable to hand variant where you see the little ghost of the cube come to my hand. It's pretty cool. And then you see the spheres on the table are just hand grab interactable. I can grab them and they have physics-enabled throwing. So there's quite a bit going on under the hood on this. So if you wanted to set this up, again, previously without the Quick Actions, the comprehensive rig features, there's a lot to learn here. So if you look at the left, this is just a sample of what's in the hierarchy for one distance grab interactable component. Ton of components. You have to know how to wire them together. You have to know what you need or what actually to add, and then how to wire them together, how to connect to get the behavior you want. That's a big learning curve for ISDK, and it's the same on the right side where you look at your player rig, your camera rig, where we have OVR camera rig, and you have all the interactors and the hands and everything under that. So quite a bit to do, and this is what Quick Actions in the comprehensive rig greatly simplifies. So we have a video here where we're going to start with this sample scene. And what's in this scene right now, it's important to note, are just Unity primitives. This is a world space canvas. The three cubes on the shelves are just like right-click, add cube. Same with the spheres on the table. There's no Interaction SDK components in this scene at all. It's just really bare minimum. So assuming this is going to play, there we go. So you can see I'm dragging the OVR camera rig interaction, which is our comprehensive rig, into the scene. I right-click on our canvas. I can add poke interaction. And there we go. And now the canvas is pokeable. I can right-click and add ray interaction. And just like that, I can raycast on the canvas as well. Now we start clicking on the spheres on the table. We add grab interaction to those. So we open the Interaction SDK menu, which is the Quick Actions menu, opens the Quick Actions wizard, and there you go, you get grab. And now we choose some of the cubes on the shelf. And you can see me auto-fixing some stuff. I'll talk about that in a little bit, but it makes it a lot easier. You can select these cubes, and you can add distance grab interaction to these cubes. So we're almost finished with that. There we go. Add distance grab, fix, and done. So that was less than a minute, and that's it. That's the whole scene. You can now poke and scroll on the canvas. You can raycast on it. You can distance grab all the cubes on the shelf, and you can grab all the objects on the table. So that went pretty fast, so we'll just take a quick sec to kind of slow down and look at what these individual steps were. Again, we just dragged the OBR camera rig interaction into our scene. We can right-click on one of the objects here. This opens the Quick Actions wizard, so I go to Interaction SDK and add an interaction type. There's the Quick Actions wizard, and this is the wizard for distance grab, and you can see there's a few different modes here. The grab relative to hand, pull interactable to hand, and manipulate in place that I talked about earlier. You could just choose from a drop-down. It'll configure all the components for what you've chosen. And then you could see the button there that says Fix All and the Fix. Those are the auto-fix buttons. And those are really cool. And if you're used to like the Oculus project setup tool, and how handy that is to just mash fix on everything, and it's, oh, great, my project works now where it didn't before. We took inspiration from that, and we included that same functionality here. So you could basically just, if you see something red, just click on it and just go. And now, all of a sudden, everything works. So the last thing in the wizard, you'll see the banners across the top, and those tell you if your scene configuration is wrong for the type of interaction you're doing. So in this example, we say, hey, look, you're missing an event system that we need in the scene. You should probably add it, otherwise your thing's not going to work. So we give you information like that as well. So once you click Create in the wizards, you see that all these interaction components are added as child objects. They're nicely self-contained with the ISDK_ prefix. If you don't want them on your objects anymore, you can just delete them, and they're gone. We try not to make a mess of your scene or really pollute it with anything, and we just say, keep everything self-contained under the objects you selected. So the results of this. Internal testing has shown that this potentially, before these introduction of the quick actions and the comprehensive rig, could take hours for a developer to make a scene like this, because it requires multiple interactions. It's not just simple as copying and pasting from sample scenes, because now you're combining interactions and saying, well, I want something from the grab scene and something from the poke scene. I have to figure out how they work together and how do I build my rig. There was a lot to it. This makes it so much quicker and takes it down to minutes. And in the case of the demo I just showed, it was less than a minute to make this entire scene. So we've talked about Interaction SDK and the new features we brought. These high-quality interactions play an important role in delivering an immersive MR experience to users, and Interaction SDK provides a robust and flexible suite of these interactions for both hands and controllers. But we can take controller actions even further. And so I'm going to introduce Andrew to talk about adding advanced haptic feedback using the Haptics SDK. Thank you.
Thanks, David. Hi, welcome to my talk, Haptics, Building for Immersion. Today I'm going to walk through some exciting titles that have used our tool, Haptic Studio, and the design process around it. Quick introduction. My name's Andrew Lazdins. I'm a haptic designer working on the XR Input Haptics team at Reality Labs. I have a background in audio hardware. Started with Haptics and Lowfelt, which was a Berlin-based startup. It got acquired by Meta in 2022. My work entails collaborating with game studios, sound designers, and developers. So what is haptics? Simply put, it simulates the sense of touch. Why is it important? In the virtual or augmented reality environment, it provides tactile feedback to create immersive and realistic experiences. It forms part of the multimodal experience. It helps improve usability. So that with that in mind, we'll introduce Haptic Studio.
Okay.
So the process of haptics can be time-consuming, requires coding to design and integrate. So the Haptic Studio and the SDK aims to make this easy for developers and designers. Firstly, to create haptics, you can import your audio assets straight into the app. Studio will then automatically extract the haptic signal using the audio to haptic analysis. To test and validate your designs, you can audition them through the headset using a VR companion app. The designs can then be exported as .haptic files, and these clips are hardware agnostic. They describe the design intent of how the controller vibrates. And lastly, you can integrate your clips into the game with a Haptics SDK. The clip exports are static, so effects such as looping and dynamic modulation can all be created at runtime according to your design intent. And the haptic files you create are forwards and backwards compatible across all the Quest devices. So for haptics in general, we have some hurdles to overcome. They're generally a low priority commitment for most developers. Work and implementation starts late in the process, usually after or alongside the sound design. Most projects contain little or no briefing, and the general approach is to just dive in and do it, really. So we'll take a look at some examples of how haptics have been designed, and we'll start with Asgard's Wrath 2. The game is developed by Sanzaru, who worked with our team closely to determine their integration workflow. It was recently named Quest Game of the Year and won the DICE Award for Immersive Reality Game. For this project, we had some unique challenges. The HD haptics were added towards the end of a long development cycle at the point where the tech stack was frozen. And due to the enormity of the game and the incredible detail to the sound design, around 700 audio assets had to be processed. So to give an example of the implementation, Haptic Studio was used for its ability to batch process hundreds of audio files into haptic clips. By using the wave export functionality, we're able to reintegrate into their FMOD workflow. And this experience and collaboration also helped us to shape our middleware roadmap. So from a design perspective, we have three approaches. We're building immersion in cinematics, creating realism with weapons and objects, and highlighting interactions with character movement. So our first aim is to build immersion, and we can achieve this by bringing the player closer to the action. For example, the first battle in the opening scene with Heru crashing through the ice introduces the player immediately to HD haptics at the same time as introducing the player to the game mechanics. The cinematics is a great example of how haptics can be used just basically straight out of the box. By adding physicality to weapon interactions, we can create realism, such as the feeling of the individual strings and notes on the siren's harp, or the charging of Alvida's bladed bow. We can highlight interactions with character movements, such as climbing, jumping, and squeezing through crevices. The hill slide mechanics is a good example of using dynamic effects where the audio parameters are tied. Audio parameters used to alter the haptics in real time as you're steering and changing speeds. If you want to check it out, I highly recommend you to play it. You can also feel a subset of the interactions with a sample pack that's in the latest release of Haptic Studio. There's also a developer success story on the Oculus blog to read. So we'll move to the next example, and we'll explore adding HD haptics to Beat Saber. The latest release comes with the Daft Punk audio pack and also includes the haptics update. When upgrading to HD haptics, we ask some questions as how do we design to not interfere with the fast-paced gameplay? How do we retain a familiar experience for existing players? And how do we design without guidance from audio? So to help answer some of these questions, a design philosophy for the haptics was established. The purpose was to create a set of guidelines to adhere to throughout the design process. And there are three categories to this approach. The first is to keep it conservative, to keep the core interactions simple, retain familiarity as much as possible for the existing Quest 2 players. The second are the practical considerations. So The core interactions are optimized by perceptual testing to achieve a consistent and impactful feeling across multiple devices. And when the audio assets are not present, we use a minimalist approach to avoid any complexity and not interfere with the game mechanics. And thirdly, the creative changes, and this is where the advanced haptics can really shine. So we want to complement and enhance the game mechanics. For example, when your saber flows through an arc from one note to the next, it will charge up like an enemy beam, then discharge into the preceding successful hit. And for the note chains, the transients we use to create a very sharp, quick pulse, and it reflects the slice layers of the cubes, and also helps distinguish it from the notes. The bombs, if not sliced, will then detonate right next to the player with a shockwave and particle dispersion. And obstacles will feel as if they're creating resistance as your sabers are cutting through them. Also, when your sabers are crossed, they'll feel as if they're generating the force. So these design approaches are reflected in our haptic guidelines. For example, we convey haptic balance by keeping a less is more approach. We're keeping the core interactions simple and effective. We're identifying user needs by designing with existing players in mind and keeping a familiar experience. And we don't want to distract or interfere with the gameplay. We're also using showcase moments to enhance and complement the game mechanics. So we'll move on to our last example by Toast Interactive. So following up from Richie's Plank experience, Toast Interactive created Max Mustard. It's a 3D platform with a nod to the nostalgia of retro classics. In this collaboration, Toast VR had a clear vision of what they wanted to achieve, which was best in class or the gold standard in haptics. And they were treated as an integral part of adding immersion into the gameplay. Nevertheless, there were some concerns around player fatigue with repetitive actions that we considered in the design approach. So in order to be mindful about causing fatigue for these highly repetitive interactions, we matched the intensity of the haptic effect to the frequency of the action. So there are a lot of different coin types in the game, and as the gold coins appear the most frequent, then they have the lowest intensity. This also allowed for the higher priority of the character interactions, such as Max's animations, the jumping, hover, kick spins, and special item collections. Looking at the interactive objects, when the vacuum cleaner or the plunger mechanic is introduced to the player additionally has to control the object on top of Max's movements. So this change in perspective is also reflected in the change from static to dynamic haptics. So for example, the vacuum cleaner intensity gets stronger as it sucks enemies in and then fires them. So this also helps to convey the layering and the depth, like bringing the player into the game and creating a sense of direct action. So lastly, we can look at cinematics. Haptics were added to the start sequence as Max flies into the opening scene, and this immediately connects the player to the character. The end sequence haptics are a mixed approach of direct action following animation and audio cues. So there's a layering effect as the haptics initially follow animation. In the middle part of the sequence, they follow the music, and then the last part follows the sound effects. So this provides an example of how you can add depth to different elements. And it also highlights the flexibility of Haptic Studio, which allows you to be creative in your approach as though you would through your sound design process. So I hope these examples have given some inspiration for your own designs and creations. If you want to know more, I encourage you to check out our open source GitHub repo. It contains examples of projects and templates in our haptic design guidelines. There's also learning materials such as YouTube videos and our in-app tutorials in Haptic Studio itself. So feel free to come and chat to us, discuss your project needs or assistance, or any assistance with haptic design and implementation guidance. And if you have any questions, our team is here to help, so come and say hi. And haptic feedback is a gift, so feel free to...
It seems like we have a few minutes left. If we want to do any Q&A, I don't know if we want to.
I would like to ask a question, if you don't mind.
Okay.
Hey, hi. Thank you very much for your talk. I have a question both for David and Andrew.
Okay.
I'm a haptics engineer myself. So one question is for interaction design for David. Will it be possible to use both the controllers and hands in one scene at some point?
Yes, probably. It depends. How exactly do you mean? Like you can use one controller, one hand, or your hand data as well as your controller data?
So yeah, at the same time. Like for example, for Pro, you have controllers which can be tracked behind the headset, right? Because they have cameras. So if you put them on the legs and you have your hand tracking, you have full body tracking. Do you understand? We can talk about it later.
Sorry, I'm having trouble hearing you actually a little bit.
Okay, I can shout as well. Okay, maybe another question for Andrew. I'm doing the hardware for haptics. Is it possible at some point in Meta, does it have a future plans to open haptics of every game to any other peripherals?
Oh. I'm not sure at this stage. I don't know. I mean, the program is agnostic, so it will be designed for everything that is compatible with Meta at the moment, like on all Quest devices. But yeah, for the future, I'm not sure. We can have a chat after.
Hi there. Thanks for the talk. I saw that in your presentation there was integration for Fmod workflow efficiency. Is that also existent within Wise or for Wise?
Yeah, that will be coming. So yeah, for our future roadmaps, we're going to have Fmod and we're going to have Wise integration. So it'll be coming later on.
Okay, thanks a lot.
Yeah.
So a question on the interaction toolkit. Specifically on the hands, I was wondering if there's any kind of roadmap towards OpenXR compatibility for hand tracking?
Oh, OpenXR compatibility.
Yes.
Yes, that's something we're looking into right now. We don't have an exact timeline for it, but it is something we're looking into for. Do you mean OpenXR compatibility as in the hand skeleton itself, or the sort of way the hand is set up, or basically compatibility outside of OVR?
Well, this may be kind of low level, but building kind of like a marionette system to drive my colliders and trying to interpret that system between like how Oculus does it versus how Pico does it versus some others, just trying to abstract the system so I could make more portable content, really.
Yes, that is something we're looking at, but we don't have a timeline for it yet.
Okay, thank you.
Earlier, when you were giving the demo on, just quickly setting up interactables, you were clicking a lot of checkboxes in the components, such as like your control schema for how you're able to grab objects at a distance and pull them in. And I immediately had an idea. Can I change those at runtime if I wanted to maybe have like a telekinesis game where I want to pull the controller based off of open hand, push it based off of like this sort of motion, obviously. And essentially what I'm asking is, are those components able to alter their behaviors at runtime?
The specific components for distance grab?
Yeah.
Yeah. So what Quick Actions does, it ends up just composing all your components into this one thing. So you can recompose them and change them after. And ISDK uses a set of interfaces to do everything. So generally, if you want to change the movement, you can either implement your own and just plug it in, or you can plug sort of our presets in there. But essentially, you get a big block of components, and you can rearrange them after you're done. It's not it doesn't bake anything into anything, so you're free to change it.
Sweet, thank you.
I don't know if we're out of time here.
Hi.
We ended at 40 or 50?
So,
It's got to be 40. Yeah. All right. So
are there any, I guess, interesting applications of haptic feedback that you've seen? Obviously, you talked about that. You talked about like certain game, like that like sword game in here. But are there any games that like really rely on like haptic feedback as like maybe a core part of the gameplay?
Rely on it in terms of like for like movement, for direction, for navigation through. Is that what you mean?
So like what I've seen is haptic feedback is used to complement the gameplay. Are there any examples where haptic feedback is like a core part of the gameplay? Have you?
Oh, okay. Rather than just being an assistant, like in sound. I mean, it's always going to be a part of the connection of the like more wider sort of multimodal experience. In terms of something that is just using haptics solely for gameplay, I don't know. Maybe we'll build one.
Right. Thank you.
My question is very simple. Are they compatible with Unreal? That's it. Unreal Engine. Can I use them in Unreal Engine?
Sorry, it's really hard to
Sorry,
hear.
it's very quiet up here, the thing.
I'm about to just... Is it possible to use your programs with Unreal Engine?
Unreal Engine for
Yes.
either one of these or both?
Either one of you.
Unreal support is something the Interaction SDK is looking into.
Okay.
And I believe
We have an SDK for Unity.
All right.
Unreal.
for
sorry.
Unreal. Okay. So Haptics SDK is for is for
Perfect.
Unreal.
Thank you.
So I know you showed the kind of graph and then the considerations of how much haptic feedback should be used at one time. Is that like a rating system you provide with the graphs, or is that more of a player feedback situation where in testing you discover this is too much feedback at one point and you kind of need to tone it down, or how does that work?
Okay, I think I got some of it. Can we just have a chat? It's like really hard to hear. Hold on.
Yeah, I think we're out of time up here, so we'll be out in the hallway, and if there's any other questions, I'm happy to hang around and answer them. Thank you.